What I've been working on for almost my entire career is called superstring theory. And superstring theory is an ambitious attempt to give a unified description of all fundamental forces and elementary particles. So one of the problems with superstring theory, which is unavoidable, is that most of its most characteristic predictions involve energies that are far beyond those that can be achieved by any human methods that we can think of, including high-energy particle physics accelerators. However, there is one important prediction which does show some promise for being discovered experimentally, and that's the prediction of a new kind of symmetry, or at least it was new 40 years ago, called supersymmetry. It's new in the sense that it hasn't been yet discovered, and if it were, that would be a new discovery. In particle physics, there are two kinds of elementary particles referred to as bosons and fermions, and all of the other symmetries relate bosons to bosons and fermions to fermions, and supersymmetry is the new kind of, or new as I said before, in the sense that it hasn't been discovered, that would relate the bosons to the fermions. It plays an essential role in the mathematical consistency of string theory. So the basic prediction of supersymmetry that experimental people can look for is that associated to every known elementary particle, there is a partner particle which shares most of the properties of the known particle, but differs in higher mass, and also the amount by which it spins, the angular momentum, would be a little bit different. So there's a very definite prediction for all the properties of these supersymmetry particles except for their masses. Knowing the mass is absolutely crucial for an experimentalist, because if the mass is too high, they simply will be unable to discover them. So the reason we've been hopeful about this is that there are several arguments why the mass should be in the range that would be accessible to the experimentalists, particularly those who are working at the Large Hadron Collider at CERN in Switzerland. People are getting a little bit discouraged because so far there's been no sign of these particles in the experiments so far. The experiments have not covered the whole region that they will eventually be able to, so there's still hope. It doesn't mean that the supersymmetry idea is wrong. It just means that it might not be accessible at the LHC, the Large Hadron Collider.